Name these pieces of equipment. The first one is a beaker. The second one is a funnel, or filter funnel. Again, if it had filter paper, it would look like that. That looks like a cone, so that there is a conical flask. So it contains some hydrochloric acid. Litmus is added. What's the final colour? So it's got acid. The colour most commonly associated with acids is red, and litmus is red in its acids, as with also methyl orange and universal indicator. Litmus in alkaline solutions is blue. That's good. The next one's, I was trying to work out what things are. Magnesium, so I'm just writing its symbols, plus HCl goes to form solution F plus hydrogen. Well, we haven't used the magnesium from a reactant, so it must be magnesium. We haven't used the chlorine from a hydrochloric acid, so it's going to be magnesium chloride. So solution F is magnesium chloride. Next one, the salt formed is magnesium sulfate. So what do we use to make sulfate? Sulfuric acid, so that would be H2SO4. Magnesium carbonate plus acid forms a solution plus a gas. Carbonates form carbon dioxide gas. Magnesium plus hydrochloric acid forms magnesium chloride. That's a solution, so let's see what it's after. The gas is going to be carbon dioxide, and the dilute acid will be hydrochloric acid. So moving on, how many different elements are shown? We've got aluminium, sulfur, oxygen and hydrogen, so 4. Next one is name 2 metal containing products. So this one and this one. So aluminium hydroxide, and the other one will be sodium sulfate. So we look at the state symbols. That's a solid and that's aqueous. So we can sort of say what's going to make the solution acidic. It talks about the OH minus ions. So what do we need to think about? H2SO4 is aqueous. So is a solution and releases H plus ions. When we say aluminium hydroxide is a solid or insoluble, and so does not form OH minus ions. Solution is 7.5. Cutting sounds and automating. So 7.5, aluminium sulfate is added. We look here, it's forming H plus ions of solution, so it's going to become more acidic. So the suggested answer would be 5.5. The next one is all about the solubility rules. Now, the 3 sulfates which are insoluble are lead, calcium, and barium. So if we mix barium ions with sulfate ions, we get precipitate. So here we've got barium ions being mixed with sulfate ions, so it will form precipitate of barium sulfate. Next one, carbonates are all insoluble apart from group 1 carbonates. So if we mix carbonate ions with group 1 compound, no precipitates formed, no PPT. PPT is an acceptable abbreviation for precipitate formed. Then next one is sulfate ions. Again, which sulfates are insoluble? Lead, calcium and barium. So if we mix sulfate ions with calcium ions, we'll get a precipitate of calcium sulfate. The next one is we look at the equation. It says a precipitate is formed. So precipitates are solids, so that means that was a solid. And here it says solution. So solutions means things which are dissolved in water. So lead nitrate solution, potassium bromide solution, AQ. Oh, AQ. There we go. And we also know that it says a solution of potassium nitrate is produced, so AQ. Lead sulfate is insoluble. It's made from a solution of lead nitrate, something which could be added to form a precipitate of lead sulfate. So the lead nitrate is producing or providing the lead 2 ions. We need something to provide the sulfate ions. So the easiest thing might be something like sulfuric acid. So now write an equation. We've got lead nitrate. It told us a formula in the question, PbNO3 2. I've suggested H2SO4. It told us in the question the form of precipitate of lead sulfate, so PbSO4. And the other thing which we haven't accounted for are the nitrate ions and hydrogen ions, so HNO3. And to balance it, we need 2 nitric acids because we've got 2 nitrate ions on the left and also 2 H+ ions on the left. What would you observe? This is where we can use the state symbols. We're mixing a solid with a liquid or a solution, and we're forming a solution, some gas, and some water. So the solid, lead carbonate would disappear, so solid disappears. If a gas is being formed, we'll see also bubbling, fizzing / effervescence. Right, the next one says sulfur dioxide is formed in reaction between hydrochloric acid and sodium sulfite. So HCl plus Na2SO3. It says water's formed and a salt. So common salt we know is sodium chloride, so NaCl, and also it tells us that sulfur dioxide gas is formed plus SO2. Now, in terms of balancing equation, we've got 2 sodiums here, so we'll probably need 2 sodiums on the right, 2 chlorines on the left, so we'll need 2 chlorines on the left. So I may have said that the wrong way around. So we can check it's balanced. So hydrogen, let's use dots, 2 here, 2 here. Chlorines, we've got 2 here, let's check we've got 2 chlorines here. Sodiums, 1, 2. 2 NaCl, so 2 of those. Sulfurs, let's do that. 1 sulfur here, 1 sulfur here. Oxygens, I'm going to use a colour. Oxygens, 3, 1, 2, 3. 1 here, and 2 here. Methyl orange. And it says the solution is acidic, so methyl orange is red in acidic solutions. What makes solutions acidic? If you scroll back up, we'll see it mentioned H+ ions to do with acidity. Well done to one of you who remembered this reading through it. So H+ ions make solutions acidic, so let's put that H+ in there. It's then neutralized. So that means the acidity has been removed. It's now alkaline. Methyl orange is yellow in alkaline conditions. Then it tells us about how magnesium is extracted. It tells us in stage 1, calcium hydroxide reacts with magnesium chloride to form a precipitate. So that must be a precipitation reaction. Next time, magnesium hydroxide is reacted with hydrochloric acid, and it forms magnesium chloride plus water. It doesn't tell you about water, but it does form water. Now, this metal oxides, metal hydroxides are bases, plus an acid, forms a salt plus water, bores. So that is a neutralization reaction. So stage 2. In stage 1, what's the other product? So let's have a go at just doing stage 1 here. CaOH2 is reacted with magnesium chloride, and it forms magnesium hydroxide. So if we try to work through this and highlight it, the magnesium here is here. The hydroxide, change green, hydroxide ions here are here. What have we not used yet? We've not used our chloride. Touch. We've not used our chloride ions or calcium ions. So the other product is going to be calcium chloride. And it's a name, so calcium chloride. So let's scroll down. This is all about preparation of a salt. So it tells us the chemicals which we mix together, here and here, and it tells us you've provided a beaker of sulfuric acid. So imagine, let's go through the stages. Firstly, here is our beaker, and it's got H2SO4 in it. We're going to start off by obviously adding the other reactant. So using our spatula, we'll add our copper oxide. And how much copper oxide did we do this? Last time when we did it, we added an excess, and the solution turned blue. So let's draw some blue solution here. And now we want to separate the two of these things. So what we need to do, we filtered off the blue solution. There we go. And there we have it. Filtered off our blue solution, and all of our that solid, the excess copper oxide was here. Now we've got our blue solution, but there's no crystals, so what we needed to do with our blue solution is we needed to heat it up to make it saturated, to get rid of some of the water. So heated it up. What happened over time? Some solid crystals of copper sulfate formed. So let's draw that in a bit darker blue. Here is some solid forming, mostly formed around the edges. And now the solution is, say, at 100 degrees centigrade. Now, if we leave it to cool down, more crystals will turn up. So we leave it, more crystals turn up. Let's draw these crystals here. But we still have a bit of solution left, so it's all quite a bit damp. So we now need to get rid of this extra moisture. So what do we need to get rid of any moisture? We'll filter it. Use filter into a beaker. We obviously might lose a little bit of our blue solution, which is absolutely fine, because you can't get all the crystals. So here we have some blue crystals, and if we look, let's just do a tiny drop of blue. Do a tiny drop of blue liquid. So they're still slightly damp. So what do we need to do? We need to pat dry with filter paper. So there's our filter paper, and we're going to pat dry our blue crystals between filter paper. So that's what we now need to write down in terms of words. So our process: mix H2SO4 and CuO. That's what we're doing here. 2. Use excess CuO. 3. Do this, I'm sure. 3. Filter off excess CuO. Then stage 4, which is this stage, heat until saturated / crystals form around edge. Then after all of that, 5 leave to cool, and then 6 hat dry using filter paper. Again, placing it in a warm oven also works equally well, but it's got to be a warm oven. What colour was copper oxide? That was black. And the final bit is what colour is other crystals of copper 2 sulfate which you formed, and they were, and I think that was everything. Do feel free to write any questions or email me any questions before the lesson. Thank you.